A coroner's conclusion about the death of BBC Radio Newcastle presenter Lisa Shaw, who died after complications of the AstraZeneca COVID vaccination. Lisa was 44 and she died in May, 3 weeks after getting her first dose of the AZ jab. She developed severe headaches after being given the vaccine and died at Newcastle's Royal Victoria Infirmary. The senior Newcastle coroner, Karen Dilke, said that Lisa was previously fit and well, but she concluded it was clearly established that her death was due to a very rare vaccine-induced thrombotic thrombocytopenia, which is a condition which leads to swelling and bleeding of the brain. Lisa joined the BBC Newcastle daytime team 5 years ago. She'd previously worked at Metro Radio, Heart Radio, Central Radio and Real Radio, where she won a Sony Gold for her breakfast show. In a statement, Lisa's family have said, "This is another difficult day in what's been a devastating time for us. The death of our beloved Lisa has left a terrible void in our family and in our lives. She truly was the most wonderful wife, mum, daughter, sister and friend. We've said all we want to say in public at this time and asked to be left alone to grieve and rebuild our lives in private."
People, but I think it's quite important to cover this because there's some new research out that is indicating that my theory about inadvertent intravascular administration, that is giving the vaccine into a blood vessel, might be causing some of the complications we're seeing. And the evidence here relates to the adenovirus vector vaccine. That's the Oxford vaccine. Presumably that's going to be the case, also going to be true for the Janssen Johnson & Johnson vaccine as well. Now this is the risk. Let me show you the risk here. It's on this screen. So the risk is that the injection is given into a blood vessel in the deltoid muscle. That is the risk that we're worried about. So inadvertent intravascular administration. Now I'm going to give you the evidence for this now, and it comes from this paper. Now this paper here is actually a preprint. It's just out. Let's look at it. And there it is there. Now this hasn't been peer reviewed yet, but I've read it fairly thoroughly and it looks good to me, although of course I can't verify the experimental data from it. But it certainly reads like a good paper. So let's look at it now. Thrombocytopenia. So thrombocytopenia is, penia is lack of, thrombocytes are the platelets, so it's a lack of platelets in the blood, and splenic platelet derived immune responses after intravenous chimpanzee adenovirus Oxford that's the Oxford adenovirus vector vaccine for COVID-19 administration. And splenic means to do with the spleen, and the spleen is an organ which is tucked just there underneath the right costal margin. So that's your spleen on that side, that's your liver on the left side, so it's tucked under there, and it has a lot of immunological functions protecting us from infections. So recently a rare and novel complication of SARS coronavirus 2 targeted adenovirus vector has emerged. Now I believe that what I'm going to tell you has also got application for the mRNA vaccines, perhaps less so, but we'll consider that later on. Now the complication is thrombosis with thrombocytopenia syndrome, TTS. So thrombosis, as you know, is blood clots where there shouldn't be a blood clot. Thrombocytopenia is lack of the platelets. So low platelet, clot formation, in other words, the thrombus is the clot, at unusual sites, and platelet activating PF4 polyanion antibodies. Now, that's a bit of a mouthful, but basically what it means is antibodies that go to the anion, so they're negatively charged antibodies, but we won't worry too much about that. The only condition where I've come across something similar before is this, heparin-induced thrombocytopenia. Now, I've been giving heparin out on and off for the last sort of 35 years, and I've never actually seen a case of this. So even that is pretty rare, but it is known about it. It is in the literature. Now, this is based on in-life and in-experiment models. Platelet-targeted autoimmunity. So the body's own immune system is targeting the platelets. Now, auto means self, of course. So autoimmunity is where we are developing an immune reaction to part of ourselves. So, for example, type 1 diabetes, the immune system targets the beta cells in the pancreatic islets of Langerhans, or you can get autoimmune thyroid disease, or autoimmune rheumatoid arthritis disease, or perhaps ulcerative colitis and Crohn's disease may also be autoimmune. So this is not unheard of, this autoimmunity. We show that intravenous but not intramuscular injection of the Oxford vaccine, adenovirus vector vaccine, triggers platelet adenovirus aggregate formation and platelet activation. In other words, what this is saying is that if that's the vaccine given there, that can start clumping together these platelets, these small cells, these platelet cells. And of course, if you get clumps of these platelets like that, that is a start of a small blood clot. That would be called white thrombus, and that can start the generation of red thrombus, which is the larger blood clot, which of course is the problem. So that shows that can happen. Now, I think I might show you the graphic now that explains this in a bit more detail. So that's what we're worried about. Now, if it's given into the muscle, and it is into a muscle where it's supposed to be, and of course the vast majority will be straight into the muscle. It would be very, very unusual to hit a blood vessel, but some people could. So you give the injection into the muscle, that is the vaccine there, and they're the platelets, and you don't get any link between the two, because when you go into the tissue of the muscle, most of that drains into the lymphatics, which of course is exactly where it's supposed to go. But if it's given into a blood vessel instead, then what happens is that the vaccine here goes into the platelets, because the platelets aren't in the tissues, they aren't in the muscle, they're in the vessels, they're in the blood. So there the virus is activating the platelets and cause them to clump together. And then they go to the spleen, which is there. Gets a bit complicated, this, but so they're the platelets, and then they activate these macrophages, these cells, these phagocytic just means a cell which eats things, so the phagocytes in the spleen. These are immune cells in this immune organ, the spleen. They produce fragments, and those fragments are picked up by these B cells, the B lymphocytes. And you might remember it's the B lymphocytes that produce these Y-shaped antibodies, or the immunoglobulins. And then here we see these immunoglobulins sticking the platelets together. So that's kind of the mechanism of what is proposed to be happening in this model, and they do give good evidence for this. So that is the problem there. Now, what they say is we show that after intravenous but not intramuscular injection, then you get this adenovirus aggregate formation and platelet activation, which of course is exactly what we don't want. So after intravenous injection, these aggregates are phagocytosed by macrophages in the spleen. Now, phage is to eat cells, cytose, cells that eat the phagocytes, and they are macro, they are big, and the phages are eating, so they are the big eating cells. And of course, normally this is absolutely brilliant because they eat up bacteria and viral particles. And here we see that that's happening in the spleen with these aggregates that are formed of platelets that have come into contact with the adenovirus vector, which of course they're not supposed to, because they should be going into the muscle. But if they go into the blood inadvertently, then this can happen according to this paper. This is followed by pronounced B cell response with the emergence of circulating antibodies binding to the platelets. So there we see the antibodies produced by these beta cells in the spleen, which were stimulated by the macrophages, which were stimulated by the platelets in combination with the vaccine, and they produce these antibodies, and they start clumping together the platelets in the blood, which causes the blood clot. And of course, as these clump together, that reduces the amount of platelets, causing the thrombocytopenia, or at least partly causing the thrombocytopenia as well. Right, our work contributes to the understanding of thrombocytopenia syndrome and highlights accidental intravenous administration as a potential mechanism for post-vaccine thrombocytopenia syndrome. Thrombosis thrombocytopenia syndrome. So there you go. I mean, this is a direct quote. Our work contributes to the understanding of TSS and highlights accidental intravenous injection as a potential mechanism for thrombosis thrombocytopenia syndrome. Hence, safe intramuscular injection with aspiration prior to injection could be a potential preventative measure when administering adenovirus-based vaccines. It's exactly what we've been saying on this channel for months now. Months we've been saying this. Because when you go to get your injection, the nurses that give it, or the people that give it, it's not as big as this, but they're told to inject it into the deltoid and then to give it straight away without drawing back to make sure they're in a blood vessel. Now, if you stick that into the muscle like that and then inject it, you will never, ever know whether you're in a blood vessel or not, because you'll pull it out and you can't see into the muscle. You haven't got X-ray eyes. So that is the problem. So we are not aspirating. But of course, if we do aspirate, and I've shown you this before, but I'll just do the demonstration briefly again. Suppose that's the blood vessel in the muscle. You stick your needle in, and instead of going into the muscle, you go into the blood vessel. When you pull back, when you aspirate, it's immediately obvious because you get blood coming back into the syringe, and then you know not to inject because you would be giving an inadvertent intravascular, whether it's arterial or venous administration, instead of into the muscle where it's supposed to go. Let's finish off this paper. Safe intramuscular injection technique, exactly as we've been saying, not recommended by the World Health Organization, not recommended by the UK, recommended that what we have formally said is this question should be answered by these authorities, and I will show you a formal answer in a minute. Consistent results with mice and human platelets. Vaccines are routinely administered intramuscularly and trigger immune response, mainly in the draining lymph nodes, which of course are under the armpit. But they go on. Based on our findings that adenoviral vaccines bind to blood platelets, we hypothesize that accidental intravenous injection of adenoviral vaccine might lead to platelet adenovirus aggregate formation with platelet activation. In other words, you would get clumps of platelets being clumped together by the vaccine if it went into the blood directly. The decline in platelet count was dose dependent and correlated directly with adenovirus positive platelets circulating in the blood 1 hour after the injection. In other words, the more of the vaccine that goes into the blood, the greater the problem. Intravenous but not intramuscular injection of the AstraZeneca type of vaccine results in a strong increase in platelet adenovirus aggregates. I mean, these are direct quotes from the paper. It's pretty hard to argue with them. Now, is this written by a bunch of numbskulls? Well, the authors are from, that's the University in Munich. Looks like pretty reputable German Centre for Cardiovascular Research. University of Munich, Division of Immunology, Transplantation and Infectious Diseases, Milan. So these are very reputable scientists from reputable institutions. Interesting, isn't it? Very interesting. Now, I've shown you my letter. I felt strongly about this, so I wrote to Nadeem. Well, I wrote to my MP, and he passed it on to Nadeem Sahawi, of course, our vaccine minister in the UK. So it tells me I can go there for further information, which of course is nice. From reports of major thrombosis with concurrent thrombocytopenia, we have not been able to identify any evidence associated with errors in administration in UK cases. Well, of course not, because you don't know. If it's gone into a vessel and you inject, you don't know you've done it wrong. Of course there's no evidence. It's ridiculous. Quite ridiculous. The very rare clotting condition reported, well, it is probably about 1 in 85,000, but that's been enough to discredit the vaccination programme. This is why this is so massively important. Reported following the administration of the University of Oxford AstraZeneca COVID-19 vaccine is thought to be due to an immunological mechanism. Well, here we see it's an immunological mechanism combined that occurs after inadvertent intravenous administration, but not after correct intramuscular administration. Right, where am I? Guidance published by Public Health England says this. It actually says there is no need to pull back on the plunger to aspirate before the plunger is depressed to release the vaccine into the muscle because there are no large vessels in the recommended injection sites. Now, this is Nadeem Zahawi, the vaccine minister. Look at it. It says there are no large blood vessels at the recommended injection site. So firstly, he doesn't know that it's not being done right. Then he says there's no large blood vessels. Is that true? Well, when you want to know about anatomy, you get this book out, Gray's Anatomy, 41st edition, which I think is still the latest edition. And you look up the relevant section. This is where you go for your anatomy definitive text. And then you look at the relevant diagram. And here we see one. So here we see the deltoid muscle around here. This is high up in the deltoid muscle, but here we see this bundle, and these dots are arteries and veins. And anatomical variations means that these could sometimes go down further. So Nadeem Zahawi's letter says this: there is no need to pull back on the plunger, aspirate before the plunger is depressed to release the vaccine into the muscle because there are no large blood vessels at the recommended injection site. No, that's what he says. But I've just shown you Gray's Anatomy points them out. Or another diagram from Gray's Anatomy. This one, hang on, this one here, can we see that? Whoa, I don't know if I can get this in. I have to put it sideways like that. There we go. So this is the, again, you can't really see this that clear, but that's the deltoid muscle there. That's the humerus. That's the injection site just there. And you can see if it goes too deep, for example, there's a nerve, 2 veins and an artery there. So that is quite conceivable, especially in someone who had a thinner deltoid muscle, that it could go too far. Or indeed there could be anatomical variations and blood vessels within the deltoid muscle. So there you go. The way I read that, that is Gray's Anatomy 10, Nadeem Zahawi's letter 0. That's what I got. Wrong completely, in my view, on 2 counts. Now, is this new stuff? Should our seniors and betters in senior positions, chief medical officers, chief scientific officers, chief advisor to the president, blah, 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 should they have known about this? Well, yes, because it's in the literature. Let me show you. Previous peer-reviewed evidence. And I'm not going to bore you with too much of this, but there's lots of it. Intravenous administration of recombinant adenoviruses causes thrombocytopenia, anemia, and erythroblastosis in rabbits. So that's evidence from rabbits. And we did see on the previous paper that mice and humans were having a similar response. Some of these are in humans as well. Adenovirus-induced thrombocytopenia, the role of von Willebrand factor, and P-selectin in mediating accelerated platelet clearance. So again, direct quote from the paper. Thrombocytopenia has been consistently reported following the administration of adenoviral gene vector transfers. So that first one was 1999. That one was in Blood, journal Blood, 2007. This one here, direct quote, thrombocytopenia is one of the complications for in vivo administration of adenovirus vaccines after intravenous injection. Human Gene Therapy Journal, 2007. Platelet adenovirus versus inert platelet adenovirus versus inert particle interaction effects on aggregation of the role of platelet membrane receptors. Don't worry if you don't understand all this, doesn't matter, but that's in the journal Platelets 2013. And again we see virus-mediated gene therapy applications are still challenged by the resultant thrombocytopenia, even though we're not sure why. 2016, it goes on. I could have quoted lots more. I mean, I'm not going to bore you with any more of those. But basically, this science has been known about for some time. So there you go. I profoundly disagree with my letter from Nadeem Sahawi. And I think, based on this paper, that it looks like at least some of these complications are caused by inadvertent intravenous administration rather than intramuscular administration. The treatment is remarkably simple. Send a circular around. I could dictate it now if Nadeem Sahar was listening. All people giving coronavirus vaccines should insert the needle into the deltoid muscle, aspirate first to make sure there is no inadvertent intravascular administration, and then, providing no blood comes into the syringe, squirt it in. And when you think about, we're talking about sort of 1 in 85,000 here. It's a really rare thing. But it's discredited and messed up the vaccination programme in South Africa and Australia and the UK. And yet this could potentially be eradicated. Now, this paper needs peer reviewed, of course, but it's a variable to eliminate. As I understand it, and I've been given intramuscular injections since I was 18 years old, there's no complications associated with aspirating. And we saw that, I showed you the video of Chinese nurses, that they all just gave a quick tug back before they injected. Why on earth not? And that variable would be gone. Then if we found out that the prevalence of this thrombocytopenia side effect was exactly the same a few months after everyone had changed the vaccine techniques, and that means I'm wrong. But no harm would have been done. It's always risk-benefit analysis. Let's do things that are safe, if it's safe to do things that are safe. Now, what's going to happen now is Dr. Fauci is going to ignore this, Chris Whitt is going to ignore this, Patrick Vallance is going to ignore this, and nothing's going to change. Nadeem Sahawi won't even watch the video. So nothing's going to change, and it's going to carry on the way it is. That's what's going to happen, unfortunately. Unless you can think of something to stimulate the politicians to issue a directive, which is more consistent with this latest data. So it's just so, why don't they just eradicate this variable instead of sending fancy letters from the Department of blah blah blah, to MPs? And I think it's Nadeem Sahawi. Look, there it is. You see that? Yeah, that's what he said. You've got the point of this video. No, seriously, if you can think of some way to get these blinking politicians to listen to us, then do so. Now, if they consider this, if they consider it, they take it to all their scientists or their doctors or their clever nursing leaders, and they say, no, this is rubbish, carry on doing it the way you're doing it, then fine. But this should be considered, and it grieves me. It really, honestly, it grieves me that it won't be, because this is not some silly academic video. These suggestions I'm making to these people in power, they have the power to issue these edicts that can save, in my view, people's lives. And if you're watching, you may well agree. We've called a few things right on this channel, to be quite honest. I mean, we called the pandemic way back in January 2020. We called the Delta variant way back when we said stop the flights from India, but alas, we were not listened to. Had they stopped the flights internationally from China when we suggested back in January, February 2020, we would have had no pandemic. But there we go, we didn't, so that's counterfactual history. But if you can think of a way of getting people to listen, then please do so, because I'm a bit stuck. So thank you for that, and of course, thank you for watching. Now, I just learned something yesterday, and the President Trump, apparently, it's been reported, is taking this zinc, a zinc supplement. I thought, that's interesting. Let's do a bit of background on that. Now, I am convinced, if you've watched this channel, you'll know this, that this stuff is going to be helpful as an immunoprotective and an immunomodulator, in that people that are short of vitamin D can be immunocompromised. But what about zinc? It's an interesting question. Now, the thing about vitamin D and zinc, I just happen to have got these from a particular supplier. You get them from the supermarket. They're just general, very cheap supplements. And when I say very cheap, the pharmaceutical manufacturers, I guess they could make 1,000 doses of each of these for about $1. You know, basically they're free. So given that these medicines are generic, well, they're not medicines, they're supplements, given that they're free, then no one can make any significant money out of it, because any reputable manufacturer can produce these literally by the ton. So there's not a lot of vested interest in promoting these in terms of financial gain. Lots of money to be made from expensive vaccines, lots of money to be made from expensive drugs, from clever clogs treatments.
The NHS has temporarily stopped some blood testing in England for certain conditions like pre-diabetes and allergies due to shortages of collection tubes. Doctors are being urged to stagger regular blood tests if it's clinically safe. Becton Dickinson, the medical device company which makes the files for the NHS, has warned of serious supply chain issues across the UK.